New pictures procured by the James Webb Space Telescope have staggered experts. Instead of broadening our perspective on the universe, these photos have uncovered a disturbing reality. Our consistent understanding is lacking when it comes to making sense of the potential outcomes of the universe in its early phases, where the theory of the Big Bang appears to reach its limits. This drives us to consider new speculations regarding its origins. The question arises, how is the universe shaped, and why does this new transparency challenge even the most experienced experts to learn more about the Big Bang and its intricate details? Shouldn't we examine the possibility that the Big Bang itself might reject standard thinking? The Big Bang was not merely an explosion in pre-existing space. Rather, it may have been the beginning of space itself around 13.8 billion years ago, along with matter and time. An unpredictability in physics and cosmology describes places where gravity is so extreme that the curvature of space-time becomes infinite. Today, after billions of years since the beginning of the universe, we see that our vast home is part of a grand cycle. For experts, this represents a fundamental piece of understanding the universe's very existence. It's crucial to understand that the universe isn't expanding into pre-existing space. Rather, space itself is continually expanding, as demonstrated by current theories. The first stars began to shine somewhere between 200 to 300 million years after the Big Bang, marking the end of the so-called Dark Ages. This was when the first bright objects combined to form mature systems. However, the rapid formation of these immense structures remains a puzzling mystery. An abundance of information emerged through the first pictures captured by the James Webb Space Telescope in July 2022. Experts revealed that the telescope had identified fascinating cosmic systems, some of which had already existed around 300 million years after the universe's formation. Surprisingly, these early galaxies were significantly smaller and less massive than the permanent structures that formed much later. This aligns with the scientific model accepted by experts, as the density of matter in the early universe was insufficient to form galaxies the size of those observed today. The discovery began with the identification of 6 glowing, red-shifted spots from the James Webb Telescope. These findings triggered one of the greatest cosmic mysteries in recent years. Although these newly discovered galaxies are similar in age to more recently recorded ones, they are nearly as large as our Milky Way. This has created a captivating puzzle. Later, after examining a series of images captured by the near-infrared camera, experts identified the previously mentioned light sources, using redshift to confirm that the light from these objects had taken over 1 billion years to reach Earth. Consequently, we are dealing with structures that existed around 570 million years after the Big Bang. By analyzing the characteristics of these systems, it was concluded that the Webb telescope had captured 6 early galaxies. Incredibly, these galaxies were so massive that they challenged conventional theories in cosmology. Instead of finding smaller galaxies, structures nearly as enormous as the Milky Way were identified, even though they had formed early in the universe's history. If we continue to investigate the data collected by the James Webb Telescope, it becomes evident that this gravitationally bound collection of stars already had over 10 billion times the mass of the Sun at that time, with one possibly unparalleled at 10 billion solar masses. However, whether this scenario is widely accepted remains uncertain. For instance, there would have been significantly more mass in the early universe than previously estimated, posing a problem. These identified objects challenge virtually all traditional cosmological theories. If even one of these massive galaxies proves to be genuine, it would contradict prior assumptions. Additionally, the density of matter in the early universe would need to be several times greater than previously anticipated to explain this anomaly. Another equally intriguing explanation depends heavily on how these grandiose systems formed, something that remains entirely unknown to us. These discoveries and the discussions surrounding the Big Bang have led some scientists to deviate from this hypothesis. Different astrophysicists with alternative views feel their perspectives are not being heard in scientific journals. Even experts who still support the Big Bang theory are frequently faced with questions that require convincing answers. These inquiries include fundamental issues, such as how something could have emerged from nothing 13.8 billion years ago. Could something truly arise from nothing, or was there some triggering event? Steven Weinberg noted that the concept of time, as we understand it, began only with the Big Bang, so this process could not have been triggered by something beyond it. A similarly perplexing question relates to the consistency of radiation and density throughout the universe. No matter where we look, we find similar densities and distributions of galaxies, nebulae, and radiation. Ordinary analysts explain this phenomenon through the theory of inflation. However, some experts take this assumption further with a theory of wild inflation. According to this idea, inflation is only stopped in specific regions, like bubbles, and continues indefinitely elsewhere. This suggests that other universes could be forming in these bubbles, each with its own unique physical laws. A key question emerges. What if our universe does not represent the whole picture? More intriguingly, what if another universe existed before our own? In this view, the Big Bang would be part of a larger cycle. Some propose that our universe is part of a greater multiverse, suggesting an eternal cycle of death and rebirth. These ongoing discoveries compel cosmologists to reconsider the early conditions and processes that govern the universe's formation and development. The James Webb Telescope's findings challenge long-held theories, pointing to complexities in the universe's early evolution and raising fascinating questions about dark matter, dark energy, and the nature of existence itself. Dark matter, often described as the unseen scaffolding of the universe, is believed to provide the gravitational foundation necessary for galaxy formation. However, the discovery of such massive structures so early in the universe's history raises questions about the role and distribution of dark matter. How could these colossal galaxies form so quickly if dark matter wasn't yet dense enough to pull them together? These findings challenge our understanding of the interactions between dark matter, ordinary matter, and the forces shaping cosmic evolution. Similarly, dark energy, which is thought to drive the accelerated expansion of the universe, adds another layer of complexity. If early galaxies formed and grew faster than expected, does this suggest that our understanding of dark energy is incomplete? Could there be unknown forces or processes at work that we have yet to identify? These questions have far-reaching implications, potentially reshaping the foundational principles of cosmology. Another fascinating hypothesis involves quantum physics and string theory. Some researchers suggest that our universe might be a three-dimensional projection of a higher-dimensional reality, essentially a hologram. This concept, while sounding like science fiction, is supported by certain mathematical models and experiments. If true, it would imply that our perceived reality is only a shadow of a more complex, multidimensional cosmos. This holographic principle could also tie into the idea of a multiverse, where different universes with distinct physical laws coexist. Each universe might emerge from its own Big Bang, with unique properties and evolutionary trajectories. This perspective opens up the possibility that our universe is just one of many, part of an endless cycle of creation and destruction. The notion of a Type 3 civilization, capable of harnessing the energy of an entire galaxy, adds another layer of intrigue. If such an advanced civilization existed, could it have created our universe as a simulation? This idea, though speculative, raises profound philosophical and scientific questions about the nature of reality and our place within it. Are we living in a constructed environment, designed by forces beyond our comprehension? These groundbreaking discoveries from the James Webb Space Telescope have reignited debates about the true nature of our universe. They challenge established theories, prompting scientists to reconsider fundamental aspects of cosmology. The early galaxies observed by the telescope defy our expectations, suggesting that the universe's formation and evolution may have been far more complex and dynamic than previously thought. At the heart of these discussions lies the Big Bang theory, the cornerstone of modern cosmology. According to this theory, the universe began as an incredibly dense and hot singularity, rapidly expanding and cooling to form the cosmos we know today. However, The newly discovered early galaxies raise questions about the timeline and mechanisms of this expansion. Could the universe have evolved in ways we don't yet understand? The concept of cosmic inflation, which posits that the universe expanded exponentially within fractions of a second after the Big Bang, remains central to our understanding. Inflation explains the uniformity of the cosmic microwave background radiation and the large-scale structure of the universe. Yet, the rapid formation of massive galaxies suggests that our inflationary models might need revision. In conclusion, the James Webb Space Telescope's revelations have opened new avenues of inquiry, challenging our understanding of the early universe and the forces that shaped it. As scientists continue to analyze the data, they may uncover new insights that transform our perception of the cosmos. These discoveries remind us that the universe is full of mysteries, and our quest for knowledge is far from complete. The more we learn, the more we realize how much remains unknown, driving us to explore further and rethink the very nature of existence.